In this video we're going to learn about geometric sequences. Before that, however, I just want to do a quick recap of the two types of sequence that you should know already. The first one is a linear sequence that looks like that. It goes up by the same number each time. So the common difference here is 3. We are adding 3 each time, and because of that we sometimes call this an arithmetic sequence. And the nth term of this sequence will be 3n minus 1, because we're talking about the 3 times table, which would be 3, 6, 9, 12, 15. And we have to take away 1 from the 3 times table to actually get these numbers. This would allow me to work out the 100th number in this sequence by doing 3 times 100, take away 1, is 299. So the 100th number in this sequence is 299. The second type of sequence you should know already is a quadratic sequence that looks like that. We know that it's a quadratic sequence because when we find the first difference, they are not the same. It's not like that. They're different. But if I find the difference of the differences, so find the second difference, I find that they are the same. So that tells me it's going to be a quadratic sequence, which means I know it's going to look, the nth term is going to look something like this, quadratic. I just need to find out what A, B and C are, and I can do that because I know this number here is always going to be 2A. So in this case here, the A is 1, 2 times 1 is 2. This number here is always 3A plus B, so if A is 1, 3A is 3, 3 plus B is 6, so B would have to be 3. And then A plus B plus C is 6 here. If A is 1 and B is 3, then C must be 2 to get 6. So it would be 1n squared plus 3n plus 2. And again, if I wanted to work out the 100th number in this sequence, I could do 100 squared plus 3 times 100 plus 2. So this is a linear or arithmetic sequence. This is a quadratic sequence, and that is how we can tell which one it's going to be. A geometric sequence is something that looks like that. Hopefully you can see here that we're not looking at the differences between them anymore. We can see, however, that the rule is we are multiplying by, in this case, 3 every time. That's what makes this a geometric sequence, because we are multiplying here. We're not adding like we were in the previous questions, we're multiplying to go from term to term. So in this case, the nth term can be written as 3 to the power n. So the first number, 3 to the power 1 is 3. The second number, 3 to the power 2, 3 squared is 9. The third number, 3 cubed, is 27. The fourth number, 3 to the power 4, is 81, and so on. So the nth term of this sequence is 3 to the power n. So again, if I wanted to work out the 100th number in this sequence, I would do 3 to the power of 100. Generally, for a geometric sequence, we say that the nth term is 3 to the power n, where is r to the power n, where r is the common ratio, which is what you are multiplying by each time. In this case, it was 3. So let's have a look at 3 quick examples. This sequence here is a geometric sequence. I know it's a geometric sequence because I am multiplying by 4 each time. Therefore, I know that the nth term of this sequence is 4 to the power n. Second example is this. Again, I know this is a geometric sequence because I am, in this case, I'm multiplying by 1/2 each time. If I do 1/2 times 1/2, I get a quarter. 1/4 times 1/2, I get 1/8. 1/8 times 1/2, I get 1/16. And 1/16 times 1/2, I get 1/32. So my common ratio is 1/2, and therefore the nth term would be 1/2 to the power n. And finally, third example, I want to find the first 4 terms of the sequence that has got the nth term 10 to the power of n plus 1. It's a slightly different form, but it's still going to be a geometric sequence. So the first 4 terms, so when n is 1, when n is 2, when n is 3, and when n is 4, let's work out each of those. So when n is 1, I'll have 10 to the power of 1 plus 1, which is 10 to the power 2, which is 100. For the second term, when n is 2, 10 to the power of 2 plus 1, so 10 to the power of 3, which is 1000. The third term will be 10 to the power of 3 plus 1, 10 to the power of 4, which is 10,000. And the fourth term of this sequence will be 10 to the power of 4 plus 1, which is 10 to the power of 5, or I'm missing a 0 there, or 100,000. And there we go. That is a geometric sequence when we are multiplying by a common ratio r each time, and the nth term is given like that.